Hello and welcome to video 36 in my Rigging in Maya series. I had planned for this to be the final video in the series, but before we move on and finalise the rig, we need to add root control support so the dog can be scaled, rotated and positioned in the scene. We also need to double check the rig for any potential bugs and eliminate those before we move on. We're almost there. Before we start work, I wanted to ask you something. Are you enjoying these videos and would you like to see more? Well, if so, there are a number of ways you can help support future content. The first is to simply head over to my Ko-fi page and treat me to a coffee to say thank you. The second is to head over to the antCGi store. Here you can download the assets for each of my courses, but don't worry, there are plenty of free downloads available too. The third way you can help is to join the antCGi club. Membership starts from as little as 99p a month, and in return you can earn yourself some exclusive rewards. These include member-only videos, a limited edition antCGi pin badge, and a discount on all antCGi merchandise. There are a few ways you can join. The first is to simply click the join button below this video and become a member of this YouTube channel. The second is to head over to my Patreon or Ko-fi pages and become a member there. So there you go, the future of this channel and its contents is in your hands. To get more information on how you can help, follow the link on the screen or in the description below. So in its current state, we could say we have a finished rig. All the systems are in place, the main ones anyway, so we can pose him, and the animator could happily animate with him. What we need to look at now is adding in root control support, so the animator can reposition the dog in the scene quickly and easily. So you see, we can move him around and that works okay. But if we scale him, yep, he gets all bloated. If we make him bigger, the opposite happens and he becomes skinny, more like a greyhound, I guess. So we need to stabilise this. Let's reset him back to the default scale and show all the systems. So the first issue we have is with the spine, tail, neck and ears. We added in some stretch systems, so these could be pulled around, but they don't take into account the overall scale of the rig. Okay, so let's update them. Let's start with the spine. So we need the scale factor node. Here it is. And take that into the node editor. Let's graph it and organise these a little better. Okay, so as we scale this down, the spine joints compress, and this is because the scale values it's using aren't being updated to compensate for the scaling. If we make it bigger, the joints stretch too far. So we need to add in the root control scale and multiply the spine length by it. So let's bring the root control in too and hide the shape nodes. Open this. If you remember, we stored the length of the spine here, but as the rig scales, this remains the same even though the length of the spine is changing. So this value needs to update as the rig scales and not remain constant. Create a multiply divide node and call it torso root scale offset. We will be using this node for more than just the spine. We need the spine length, so copy that value and add it to input 1x. Now connect the root control's scale y attribute to input 2x. So what we are doing is multiplying the spine's length by the rig's overall scale. We can use scale y because it's the most likely attribute to be used when somebody's scaling the rig. We can now replace input 2x in the scale factor node with the output from our scale offset node. So connect output x to input 2x. If we scale the rig now, the spine remains in proportion. It no longer shrinks or stretches. Okay, let's move on to the tail. So we need its scale factor node. Copy its length value from input 2x and paste it into input 1y on the scale offset node. We have 2 more slots in this node, so we might as well use them, rather than create new nodes. Let's connect scale y to the other inputs now, so input 2y and input 2z. Because we used input 1y, we need to use the output y attribute, so connect that to the tail scale factor node's input 2x attribute. Okay, now the neck, and it's exactly the same process. Import its scale factor node, open these, copy the neck length from input 2x to input 1z on the scale offset node. So that's this node nicely filled without any wasted space. Now connect output z to input 2x on the neck scale factor node. So let's try this now. I'll hide the polygons. There you go. The neck, spine and tail all maintain their sizes, no matter how we scale the rig. Okay, time to repeat the process, but this time update the ears and the tongue. Now I'm just going to speed through this, but it's exactly the same process of updating the length value in each system's scale factor node. Okay, those are done. Let's reset the rig. And bring back the model. If we scale him now, we still have an obvious problem. But what we've done so far is only fix half of the issues relating to the scaling. What's happening now is the follicle joints aren't scaling with the rig, so this is why he's puffing up. You see, we can scale this joint because some of the scale attributes aren't locked or connected. The problem with the leg is we don't have this option because the joints scale are being controlled by the stretchiness and also the volume preservation we added in. And you may end up having these in your spine, neck and ears too. So using the scale attributes directly on the joints isn't an option. Let's find the follicle joints. So here we have the joint, and each joint is sat beneath a follicle. So what happens if we scale the follicles instead of the joints? You'll see the model scales. So we could use the actual follicle scale attributes instead to compensate for the rig's overall scale. Let's set the scale of the rig to 2, so we can do a quick test to see if this will work. Now select the follicles and set their scale to 2 as well. Okay, that looks like it worked, so we can use this approach to help us. Select the root control and open the connection editor. We have the scale attribute here, so now bring the follicles into the right side and simply connect to each follicle's scale attribute. Okay. Now as we scale the rig, the torso maintains its shape. So now we need to update the rest of the rig's follicles, so the legs and the neck. And as you can see, there's a lot of them. So I'm just going to use a script to do all the hard work for me. All this will do is list the follicles and go through each one connecting the scale attributes to the root control. Let's close this and move this over. And let's select and run it. There we go. The legs popped back into shape. Now ignore these warnings, this is just because I already connected the spine. Let's test this now. Okay, there we go. Rig scaling is now supported. We can still pose the rig too, no matter what scale it is. And the volume preservation still works. Okay, cool. Alright, so now I just want to squeeze in a quick update to the spine. I know this isn't related to the root control, but it's something that needs to be mentioned, just in case you want to add this into your rigs as well. If we move the middle spine control, you will see that the chest and lower back areas move too. Now this may be fine with your rig, but what if you want to restrict the movement to the middle of the spine? Okay, let's hide the systems. We just need the follicle joints. What's happening is the joints at either end of the spine are rotating as the spine bends. Let's hide the model and show the ribbons. We can see it deforming as the control moves, which is causing the start and end to rotate too. What we need is to lock the end follicle joints. So what we can do is simply constrain them to the controls. Select the upper spine control and the follicle joint and apply an orient constraint. Now do the same at the opposite end, constraining the joint to the lower spine control. Let's try it now. We will see it better with the model in the scene. Okay, that's much better. Now unfortunately we won't eliminate the slight movement we have at the end here, and this is because we're using an IK spline. But this has helped to lock both ends of the spine down. We can now move the dog and scale it. So let's move on now and test to see how it holds up when being rotated. Okay. There seems to be some movement in the legs, round here. They look like they're twisting. Let's hide the model and bring back the systems. I'll switch to the default light too so we can see things a little clearer. Okay, so the ribbons are twisting as the rig rotates, so we need to stabilise these. Let's bring the outliner in. And what we need to find are the angle IK handles we added to help maintain the crease in each bend of the ribbon. Let's filter the outliner. So here they all are. Okay. Let's look in the attribute editor. So originally we used a single chain IK solver, and this worked earlier on when we weren't thinking about the root control. But we now want to rotate the dog using that root control, so we need to change these. So first, change it so it's a rotate plane solver instead. Now update its pole vector attributes so they're all 0. Okay, so on this particular IK handle we didn't see much of a difference. So let's update the others. So change to a rotate plane solver. We can see a difference with this one. You see it's now twisted, so it does look worse, but bear with me. Now go to the pole vector attributes and set them all to 0. And there we go, that's corrected it. Now let's do the next one. So rotate plane solver. Set these to 0. Good, that's one leg fixed. It's also stable as we rotate the rig. Perfect. Okay, I'll just work through and update the rest of the legs. So those are all done and updated, and they no longer twist as the root control rotates. Okay, here we go again. We can translate and scale, and the legs no longer twist if we rotate. But let's rotate it a bit further. Right, so now we have an issue where the spine is flipping. Let's take a look at what's going on. So the ribbon is twisting, and this is because of those control joints. Because they're constrained to the controls, they end up with values on the rotations as the rig rotates. And if you remember, we used these rotation values to drive the roll and twist attributes on the IK spline handle. So this is triggering the roll and twist when we don't need it. So we need another option. Something that will move with the rig, but still have 0 values on its attributes when it's not rotated. Well, why don't we use the main controls instead? You see, the rotate values here are still 0. Makes sense, really. Okay, let's go to the node editor and reconnect these. So, first bring in the control joint, and let's organise this. Okay. So rotate X goes into the IK handle. It goes here to the roll attribute. Let's open the twist multi-node, and rotate X is connected to this too. So let's bring in the lower spine control and update these connections. I'll just check that this is still rotate X that we need. Yep. So connect rotate X to roll, and then rotate X again to the spine twist multi-node's input 1X attribute. Okay, so the ribbon looks much better. It's back to being level. So we are just using the control instead of the joint to drive the roll and twist. Let's try it out and make sure the twist and roll still works. Yep, looks good. Let's update the middle control next. And this is slightly different because it doesn't affect the IK. It just twists the follicle joints. So let's bring in the control joint and organise the network. So just like before, the rotations from the joint are driving the twist, so we need to instead use the control to stabilise things. So we just need rotate X going into all 3 of the input attributes. Let's delete these, and instead use the rotation from the control. Okay, that's done. Let's try this now. We can't really see it because it's affecting the follicle joints, not the ribbon. So we should probably bring back the model. There we go. That's better. Okay, on to the final control joint. So let's graph this in the node editor. This one is a bit easier to update because the X rotation just goes into the spine twist plus minus average node. So it's just one connection. So bring in the upper spine control and open it. We want to reconnect this rotation here. So connect rotate X from the control to input 1D0. Okay, great. And that's much more stable. Okay, another issue. It looks like the whole spine flips as we reach 180 degrees. Let's hide the model and see what's going on. So the whole IK handle is flipping by the looks of things. So let's select it. And under the Advanced Twist Controls, click the Enable Twist Controls checkbox. And this instantly fixes the flipping because it's helping to stabilise the spine at more extreme positions. Now, depending on your rig, you may need to change the forward and up axes. So I would recommend experimenting with those as you rotate the rig. Okay, that's the Y rotation issues fixed. Let's try another orientation. Maybe Z this time. Okay, so the ribbon is now staying level with the world instead of rotating with the root and the rig, so we need to do another quick update. Go back to the attribute editor and the Advanced Twist Controls. Change World Up type to Object Rotation Up. This will make the IK handle follow an object's rotation instead of trying to maintain the same one as the scene. It makes sense to use the root control. So add that to the World Up Object text box. And the ribbon snaps into place. And it matches the orientation of the root control now, so follows with the rig. Let's bring back the model. So now we can rotate him anywhere and the rig follows. And we can scale him too. Perfect. Okay, so that's root support added, and we also squashed a few bugs along the way. The rig is now in a better position for us to start thinking about finally finishing him. So in the next video, we will lock it down while also doing some final updates to make it more animator friendly. Okay, another video over. I hope you enjoyed it and learned something new. Thanks for watching right to the end, and remember to hit that like button and also subscribe to keep up to date with future videos. If you have any questions or suggestions, please post them in the comments below, or alternatively, why not join the antCGi community Discord group, where me or other members of the community will be more than happy to help. Remember, to help support future content and keep these videos free, please visit the antCGi store or join the antCGi club. Alternatively, if you would just like to show your appreciation for these videos, why not treat me to a coffee at my coffee page? The link is on the screen now and in the description below. Thanks again for watching. This is antCGi signing off, and I will see you on the next one.